Welcome to lecture number 4 for ECE476 Advanced Embedded Systems. Here we're looking at subroutines with the Raspberry Pi Pico and Python. So again, kind of where we're at, this is the course 476 Embedded Systems, where previous lectures we looked at introduction to the course using Thani, MicroPython, loops and if statements. Today we're looking at subroutines. And by the end of today's lecture, we should be able to do something like calculate the damage with the D&D spell Ice Storm. So I've got a bunch of subroutines. I'm going to roll 4 6-sided dice, 2 8-sided dice, add them all up, and determine the odds of getting so much damage. So when you do that, for example here, there's a 0.0015 chance of doing 10 damage with an Ice Storm spell, 5.95% chance of doing 19 damage, and so on. So let's start out. A subroutine, it's a program that you can call from other programs. Now, these go by various names like functions in MATLAB, subroutines in C, definitions in Python, and they all serve the same purpose. They break your program into smaller routines which can be tested. That supports bottom-up programming and top-down programming. That also allows you to reuse code from program to program, which is going to be really useful later on when we get to like the LCD display. I don't want to write that from scratch every time. This lecture looks at how subroutines are defined in Python and how to return parameters to the main routine. Now in Python, the format for subroutine is as follows. There's a command def, that's your definition. This is the name of the subroutine, this one say hello. These are what's passed to the subroutine, nothing's passed to it, and the semicolon. Again, in Python, that tells Python this is the start of a loop. So everything after the Python that's indented is part of that subroutine. The simplest subroutine you can get is this one. Nothing's passed to it, nothing's returned, and it just does something. In this case, it says hello. So when I call it, it says hello. So if I try that in Python, currently say hello is not a valid Python command. If I run this code, let's bring it down so you can see it, tell it to run, what happens is it defines the subroutine, then here's my main routine. The main routine calls that subroutine and it says hello. I could call it twice, which case when I run it, I get hello, hello. Once I define that subroutine, I can actually use it from the command window. I can do say hello, call this subroutine, and it says hello. So it's basically what a subroutine does. It defines a set of commands that I can call over and over again. Again, what's significant, that semicolon is important. That tells Python this is the start of a loop. Indentation is important. That tells you what is part of that loop. This bracket says nothing's being passed to it and nothing's being returned. We'll give examples of returning statements in a little bit. So suppose you do want to pass parameters. For example, let's have a program that counts to n, and n can vary. In that case, I'm going to define a subroutine, count to n. This is the parameter that's passed to it. When I get to that subroutine, I'm going to count for I equal to 1 to n plus 1. Again, in range commands, I stop when it's equal to. So to count to n, I need to go slightly higher than n. I'll then print what I is, not do a whole lot, and then count to 5. Go to Python. So here's the command. If I say count to 5 and run that, it counts 1, 2, 3, 4, 5. Change that to 6. It now counts to 6. And again, now that I've defined it, I can use it in the command window. Count to 4. Now when I hit stop, what stop does, that clears out all the subroutines that are defined. So now in the command window, if I type count to n of 5, it says error. I haven't defined that subroutine yet. If I run this code, it now defines that subroutine, uses it. I can now, since that subroutine has been defined, it's in memory, I can now use it. Count to 3. So that's passing one number to a subroutine. I can pass multiple parameters. Like if I want to pass 2 parameters, I can say multiply, pass a and b. I'll calculate c as the product of a and b, print out the answer. So now I can say, now that that command exists, let's multiply 4 and 6. And I get 24. I can do that from the command window. Let's go to multiply. If I clear out the memory, currently multiply does not exist. Gives me an error message. If I run this code, it defines the subroutine multiply, executes this 4 times 6, and I now have access to the multiply command. What is 8 times 7? 56. With subroutines, I can return parameters. To do that, I need to use a return statement. So if I want to say multiply a times b, I want to know what the answer is. In that case, when I exit, it'll return whatever c is. So if we say x equals multiply 4 times 6, the answer is stored in x. I can now print x. And from the command window, I can say, okay, c is multiply 8 times 7, print c. So now when I run it, I now have a command. 4 times 6 is 24. The answer is 24. I can see that x has been created. I can return multiple parameters. For example, if I want to do operations like addition, subtraction, multiplication, division, I can do those 4 operations and return them. When I return, I only return one parameter. However, that parameter could be an array with multiple terms. In this case, I've got 4 terms. When I say, what are the operations of 4 and 6? I get 10 minus 2, 24.6. So what that is 4 plus 6 is 10. 4 minus 6 is minus 2. 4 times 6 is 24. 4 divided by 6 is 2/3. Once I do that, I have the command operation available from the command window. So this is if I receive a single variable, it will receive that as a string. I could pull those out separately. If I receive those as A, B, C, D, it will pull those out separately. So again, going back to Thani, if I just have the 4 operations, 4 times 6, it stores it in an array. If I receive those as 4 separate parameters, it pulls out A is 11, B is 5, C is 24, and D, since it did 8 and 3, is 8/3. And those brackets, they're optional. You can include them, you don't have to include them. This also runs. So, with that, I can do things. Suppose I have this circuit, and I want to find the resistance between A and B. Well, to do that, I need to add resistors in series and parallel. For example, let's say 200 is in series with 300. That gives you 500. 500 is in parallel with 450, which is something. It's 1 over R1 plus 1 over R2 inverse. In series with 75, in parallel with 250, in series with 50. Find RAB. Well, this is where subroutines are kind of useful. I can define the subroutine series. I'll put 2 resistors in series. They add. In parallel, they add as the sum of the inverses inverted. With that, I can say, let's add 200 and 300, call that RA. RA in parallel with 450 is RB. In series with 75, RC. In parallel with 250, RD. In series with 50, and I'm done, RAB. Go into Python. Again, here's my circuit. Run it. And it says my answer is 188 ohms. Now what I can do is I can change these numbers. Change that to, say, 600 ohms. It's now 198.04. I can recalculate the resistor if I change terms. And I can do quite a few circuits just by adding stuff in series and parallel. So those subroutines kind of give me functions that I can now use. And once I define them, they're available in the command window, such as what is the RF is parallel, ARALLEL, of 520 ohms and 630 ohms. $284.86 ohms. I could define another subroutine saying I'm going to input R, that 300 ohm resistor, and now calculate the resistances. So what that subroutine will do is I'll use the other subroutines. Subroutines can use subroutines. Will be take whatever R is, put it in series with 200, in parallel with 450, in series with 75, in parallel with 250, in series with 50, and I'm done. Return RAB. Now with that subroutine I can do a for loop. What is the total resistance when R is 100, 200, and 300 ohms? I must spell that. 200 and 300 ohms. So for each one, it's going to sit there and calculate what is RAB and print them. What I get when R is 100 ohms, answer is 176, 200 ohms, 183, 300 ohms, 188. So that's kind of some things you can do with subroutines. I can create my own functions that I use later on. Another example. Convolution we looked at before. Convolution actually is pretty useful. It's really painful by hand, but once you come up with a subroutine that does convolution, I can use it. And with that, I can come up with the probability of rolling different die rolls, like 2 6-sided dice, I think that's flaming sphere, 3 6-sided dice, a shatter, and so on. You basically calculate the damage in different Dungeons and Dragons spells. So to do that, let's come up with a couple functions. Let's come up with a function called linspace. This is similar to the MATLAB linspace command. I want to go from x0 to x1 in steps of dx. So to do that, I start out at x0. As long as I'm less than x1, keep going. Take a, append it with x, and increment x by dx. Keep going until I get to the end. When I get there, return a. When you write code, you want to test it. So here's my function linspace. Let's see if it works. I'm going to come up with a function called display. I will display whatever that matrix is. So for each element of A, I'm going to print k, the element, and the value of it. So let's test it. Let's go from 0 to 5, steps of 1, and display it. If I do that, I'm going to go elements 0 through 5. The count goes 0 through 5. Okay, so that seems to be working. Now that that works, let's write a routine that generates a uniform distribution over the interval a to b, like 1 to 4. I'll define a subroutine. I'm going to pass the two parameters, a and b. I am going to count, or the probability of each term. The number of terms is b minus a plus 1. So if it goes 1 to 4, the difference is 3, plus 1 because there's actually 4 elements. Now for the start of the array, starting from 0, I'm going to go up to A, start with a bunch of zeros. That's this guy right here. I'll then go from A to the end. Again, in Python, you stop when you're equal. So to get to B, I need to increment it slightly. Go B plus 1. The probability of each roll is going to be 1 over n. So for a 4-sided die, it's 1/4, 1/4, 1/4, 1/4. Kick out when I get to 4. Anytime I write a program, test it. So I'm going to see, do I get a 4-sided die? Or in Python, let's see, that's this guy right here. I've got a 4-sided die. Check the numbers 1 through 4. That seems to work. Let's try a 6-sided die. Take the numbers 1 through 6. Okay, seems to work. Let's try an 8-sided die. Numbers 1 through 8. Okay, that all looks good. Now, let's write a subroutine for convolution. Again, with convolution, what I do is I take the first array times the second array, flipped, shifted, add them all up. Or just take it on faith, that's convolution. Once I get a convolution routine, I can say, what is a convolution of a 4-sided die and a 6-sided die? So I'll input a 4-sided die, 6-sided die, convolve them, print the result, and here's the probability of rolling the numbers 0 through 10. So there's no way I can get a 0 adding a 4-sided die and a 6-sided die. No way I can get a 1. There's the chance of getting a 2, 3, 4, 5, 6, 7, 8, 9, 10. So here are 2. I've got the linspace, display, uniform, convolution. So I can say 4-sided, 6-sided, convolve them. I could try, let's try 2 6-sided dice. I already have that. What is a 6-sided die and a 6-sided die? It helps if you define the dice, the variables correctly. That is 2 6-sided dice. I get the numbers 2 through 12. Let's try 2 4-sided dice. I get the numbers 2 through 8. Okay, that's kind of fun. So with that, let's do something. What is the PDF for rolling 2 8-sided dice and 4 6-sided dice? That's the D&D spell Ice Storm. Well, to do that, I've got all these subroutines that I defined. Let's use them. To do that, let's go over here. I'm going to define a 6-sided die, 8-sided die. 2 6-sided dice convolve the 2 6s. 4 6-sided dice convolve 2d6 and 2d6. 2 8-sided dice convolve a d8 and d8. Put it all together, Ice Storm is a convolution of 4 6-sided dice and 2 8-sided dice. So there's the probability of doing damage. It's going to be 0 through 40. And here's the chance of doing each set of damage. And I can vary that. If I want to just look at what is a 6-sided die, numbers 1 through 6. Let's look at 2 6-sided dice. Gives me no chance of 0, 1, numbers 2 through 12. Let's do 4 6-sided dice. Numbers up to 24. Let's do 2 8-sided dice. And I can do other spells as well. For example, I think Firestorm is 7 10-sided dice. I can find that with convolution. Basically with subroutines, I can define these routines and then use them. to do things like generate random numbers, probability density functions, convolve stuff, and find out what I really care about, what's the probability of doing so much damage with an ice storm spell. What I can also do with convolution is I can multiply out polynomials. When I do that, that's actually convolution. So for example, if I want to say what is 2 plus 3x plus x squared times 7 plus 6x plus 5x squared plus 4x cubed, what I would do is the ones term is 2 times 7. The x term is 2 times 6 plus 3 times 7. The x squared term be x squared times 7, 3x times 6x, 2 times 5x squared. That's actually convolution. So what I could do is input these polynomials as matrices in increasing powers of x. So A is 2, 3, 1. B is 7, 6, 5, 4. Convolve them, display the answer, and that's the product. So it's 21 plus 32x plus 34x squared plus 28x cubed plus 13x to the fourth plus 4x to the fifth. So anyway, that's stuff you can do with subroutines. So subroutines are exceedingly useful. With subroutines, you can start building more and more complex functions. Subroutines can be written in Python. They're similar to what you write in MATLAB as well as C. You can pass parameters, similar to the way you pass parameters in MATLAB and C. You can return 0, 1, or multiple parameters, again similar to MATLAB and C, with slightly different and simpler syntax. And subroutines are just darn useful. They let you create functions, which can be used over and over again, saving time and writing programs. But one thing to note is when you do write subroutines, do kind of like what we did in this lecture, test your code as you write it. So here, like for the ice storm spell, I didn't write it all at once. I had a couple functions. Let's have a linspace and display, write those routines, test them, make sure they work. Once that works, let's come up with a function uniform. Generate a uniform like a 6-sided die, numbers between 1 and 6. Once that works, let's add a convolution routine and test it. Once that works, I can start doing some fun things like the probability of doing X damage in an ice storm spell. So that's lecture number 4 for ECE476, use of subroutines. In the next lecture, we will look at doing binary outputs on your Pico board. We're probably going to get to your Pico board.